Good morning, everyone. Welcome to week 7. I hope you've had a good flex week. I'm sure many of you are tired, no doubt. A lot of you got iteration 1 in on Monday. It's crazy to think that's 48 hours ago. It feels like just a moment ago to me. I do hope you've kind of like had a moment to breathe since then. I hope that also you are doing the peer review as well, because the peer review is an important part of this iteration, and it helps your tutor figure some things out. So we tried to make it a little bit easier with the Google form, but we'll see how we go on that front. In terms of where we're at now, besides iteration 2 being due and the peer review, we're pretty much just on the final run of COMP1531 now, which is doing iteration 3. It was released to your project the other night. And in terms of the experience that you all have with this, typically what we find is that iteration 1 is not a lot of work, but some students find it kind of, I guess, challenging anyway, because it's like all the new stuff. Iteration 2 is really the hump where things kind of feel the most painful, and that's because the volume of work's increased and people are still figuring out a lot, and there's new concepts and a bigger expansion. Iteration 3 though tends to kind of be back on the easier side, I guess, where there is still a lot of work, but it's all Flask, it's all the same kind of stuff. There's not really any massive new programming concepts. There's a couple of tiny things. It's just kind of like it's the manageable iteration. So for those of you who are feeling stressed, it should be very okay, particularly those who just make an effort to try and get organized this week. So that's super exciting. Tomorrow at the end of the lecture, we will talk about iteration 3. Iteration 3 was deployed to your repo, I believe, on Monday night, Tuesday morning. If it's not on your repo yet, I would suggest checking your merge requests, and if it's still not there, maybe post on the forum, maybe post publicly so other people can post, because I've definitely talked to a number of students that that have it. So it's probably floating in a merge request, etc. So in terms of the marks, in terms of auto marks and whatnot with iteration 2, the auto marks were relatively high. It's hard to tell because we don't really care how high the auto marks are. It depends how that balances against the manual marks. But yeah, the marks are relatively high, and that's somewhat expected from from a group work course. And the question about does that mean the exam will be harder? I mean, we have a sense of how hard the exam should be at the start of the term. We don't really pull levers too hard, etc. So that's all well and good. I think that's all the admin. My internet's better now, so hopefully we don't have any slowness. Hopefully that has an improvement. Let's get on to today's stuff. So the cool thing about week 7 is that for the first half of this week, today, it's all waffle stuff. We're not doing any programming today, which is kind of cool comparatively, because I know definitely some people just kind of get a bit tired with these things naturally, because it's all this programming, etc. So today's just kind of going to be talking a bit more about engineering, and the topics today, which are requirements as an overview, and then looking at requirements in terms of how to describe them in a bit more of a human way. These are really exciting topics as far as I'm concerned. Funnily enough, not specifically today's lecture, but this particular topic broadly is what actually got me interested in teaching this course, because when we think about software engineering, and let me get into the lecture deck here so we can really get stuck into it. When we think about software engineering, or when I deal with software engineers, the importance of requirements and understanding a system are grossly understated. It's just something that a lot of students or even people in industry sometimes aren't going to get their head around, because when people think of programming, they think, oh, it's writing code, and then as they get better, they think, I have to test that code and I have to design that code well. That's how I'd see a lot of students' kind of brains work. However, I think there's a very strong argument to say that the most important part of building a system is figuring out what you need to do. It's actually understanding the problem, and this this again can be applied to such a wide array of parts of your professional life. So it's good to get into, and we're going to be talking about requirements broadly, how to find them and how to collate them. And before we get into this, it's like someone's like, what are requirements? They are, there'll be a formal definition on the next slide anyway, but that is the specification that tells you what to do. When you do the project, we've written the requirements for you. We say, here's the interface, here's the rules. Here's the rules that if you follow, you will succeed. But in kind of reality, when you're managing your own projects or your own activities, you often have to actually define your own rules because someone's come to you with a problem, right? My sister, my sister the other day, this is very random, but she messaged me and she was like, I want to build how much does an app cost? And I was like, I don't know. What do you want to build? She was like, I want to build like a social network for COVID or so. I didn't ask any questions because I was like, I don't know. I'd still have to get back to her. But, the worst thing people can do is be like, I got a code. Oh, how does this work? Let's do this. Should this be on Android or iOS? She's like, what should we write it in? The first question is like, what are you actually doing? What are you trying to solve? And that's where requirements comes in. It's the step before you even think about a solution. So obviously it fits into the first part of this. This diagram comes up every second week. It's the yellow part that happens before the blue part. So again, most people start off programming doing the green. Courses like 1531 make you think a little bit about purple and blue. And we're really talking about a lot of yellow today. So, the IEEE, one of those, international standardized bodies, defines requirements as a condition or capability needed by a user to solve a problem or to achieve an objective. So what I like about this simple definition is it's essentially saying that a requirement is a description of what is needed to achieve an objective. If you can't it's how you define success fundamentally. Because if you can't define success, you can't achieve success. Otherwise, you're just floundering. So we can think about this more broadly though as like it's an agreement of work to be completed by all the stakeholders in a project. So who are stakeholders? They are people who are invested in the success of something. So when UNSW goes and says, oh, we're gonna go from semesters to trimesters, the stakeholders are everyone from students to staff to researchers to building managers to security to UNSW, like literally everyone in that case. It's an agreement and understanding of all the work to be completed. And you see this all the time, right? Like it's planning, but like planning before you actually say, we're going to use this type of material when you're building a building. It's actually like, where are we going to put the second airport in Sydney? What is it going to have to do? How many planes is it going to have to come in every day? How big is it? Which way are the flight paths going to go? It's like, if we do these things, then we have succeeded at what we're trying to do. So agreement of work to be completed by the stakeholders and essentially a bunch of descriptions and constraints of a proposed system, right? So I just gave that airport example then. Well, descriptions and constraints could be, okay, well, we need to build this system, but it needs to do this much, or it can't do this. It's really, again, as I said, it's the rules around it. There's a quote here which I really like. The hardest part of building a software system is deciding what to build. No part of the work so cripples the resulting systems if done wrong. And this is why I think this topic is the most interesting to me, because it's the most impactful one when you get it wrong. If you try and describe what defines success and what constraints you're working to, if you describe those things incorrectly, you have a world of pain, because everything you do after that doesn't work well, and this kind of comes back to that lecture, if you remember back in week 3, where we talked about verification and validation, and we talked about verification as that a system is built right, and validation, which is starting to get into this area, is that a system is that the right system was built. So if you remember that definition from the earlier lecture, it's like, this is all about figuring out what the right system is. Because validation, which we kind of talk about as part of this, validation is looking at the system you built, looking at the system that we said we need to build to be successful, and seeing if it matches that. So that's what requirements are in a nutshell. Now, a very kind of, this concept isn't that dear to my heart, though it's fairly kind of important in the scheme of the education on this topic, because you'll see it come up in a whole bunch of places. But when you're defining requirements, and if you think about requirements, think of them as just like a to-do list of items. So for instance, if we said we're going to design COMP1531, but before we even design COMP1531, we start writing a list of requirements about what that system should be. And maybe the first requirement would be that we need to teach the basics of testing, or the basics of testing shall be taught. Or another point might be like, what is the other kind of key things we do in this course, right? The fundamentals of HTTP and a web server shall be taught as well. So this is kind of how you would write requirements in a way, right? There's no structure to this specifically. It's just you're defining success. If the fundamentals of HTTP and web were taught, you've succeeded. You have designed and implemented the course correctly. But when it comes to writing out these requirements, we can categorize them into this functional and non-functional bucket, where functional requirements specify like a capability or service that a system should provide. It says what the system does, and non-functional requirements tend to place a constraint on the system and say how the system should achieve that. So if you think about, I think this is a very confusing topic personally, and even looking at it for years, I still get tripped up on it. We've also put a link here which kind of elaborates on this a little bit. I would recommend you read this. It's a very short page, but they give some kind of examples of the differences between them, examples of functional requirements and non-functional. You can see here the functional ones, saying the sales system should allow users to update customer records, and the software system should be integrated with the banking API. Functional tells the what, or what capabilities it has. Non-functional tells the how or the constraints. So you can see here, every unsuccessful attempt by a user to access an item of data shall be recorded. So the reason I think functional and non-functional requirements are kind of hard is because I don't think there's like a really, really clear-cut distinction between them. And I see this all the time with students, right? Where a student looks at this and says, oh, this is telling me what it does because it records it. Okay, if a user accesses something, we're recording it. That's a capability. That's what we're doing. And I think that's kind of one of the harder parts here, because I think it's very easy to spot a non-functional requirement because it just looks like that. It's like employees should never be allowed to update their salary information. That sounds like a constraint, doesn't it? That sounds like a how to go about the what, So it's easy, I think, to look at that and say, oh, that's a non-functional requirement. Functional requirements, I think, are a little harder, because I think ones like something like this could be mistaken as that. But the best way, I think, to think about it is that, functional requirements should be giving you something, and non-functional requirements are kind of taking that away a lot of the time. So when you look at something like this, I think this one is very borderline. If you just gave this to me in a vacuum, I don't even know what I would say to it, to be honest. But in this case, it's kind of like, it's trying to constrain the system, right? It's trying to limit it, take control of it, etc. So that I can understand why it's written here as a non-functional requirement. Blake says a functional requirement is usually the ones that the end user would see directly. I don't know if that's the case. Sort of. Like, if a functional requirement is something you can do, if it's a capability, then the user's probably going to interact with that in some way. But they'll also kind of feel a non-functional requirement. Like an example of a non-functional requirement that I think we have further down here on the slides, right, is that if you're building a system, a functional requirement might be that the system needs to send a notification to all users whenever there's a new post. Think about this like your UNSW Streams app, or someone comments on an existing post. So you're describing a capability, notifications when there's something to be notified of. And then a non-functional requirement says that the system must send emails no later than 30 minutes after from such an activity. And it's like, in this case here, you're kind of putting a constraint on it. You're saying, yeah, this is what I want you to do, but here's a how, here's a specific way. you're narrowing the scope a little bit. So this one I think is much clearer. And when we ask you questions about this on the exam or something else, we tend to ask questions that we don't think are super ambiguous either. You know, like I would expect all of you to be able to tell if we gave you both of these and we said, well, if we gave you both of these and we said which one's functional and non-functional, by the end of this course and everything else, we'd expect you to be able to tell that one pretty easily. Some of them are hard though. So when you are reading up on this, and I would recommend Googling around too, because there's lots of different websites that explain it different ways, and some suit different people's style of understanding better. You're always going to see about 10% of them that you're like, I don't. Okay, so don't stress about that though. But yeah, that's the gist of it. They're just kind of different ways of categorizing requirements, because then you can say over here, this is what we need to do, and these are some constraints on it. But yeah, interesting stuff. Obviously, you could subcategorize those further, but these are two very kind of common terms you might see out in the world. You might see people be like, do we have a list of our functional requirements? And you're like, oh, I remember that. That's the what we do. Sure. Okay, let's think about all the capabilities that we need to provide. So that's it on functional versus non-functional. In terms of actually like figuring out requirements, because I think it's like it's okay to define a requirement, which is hard anyway because it varies so much. But a big part of this lecture is about figuring them out yourself. Because again, being given requirements is somewhat easy, and the example I would give you, and I give this example most terms, is that it was something I was exposed to with SunSwift, but in 2015, we tried to get a car legal on the roads, like a solar car, like legally allowed to drive on the roads, like permanently kind of thing. And what was very different about that experience for us was that previously when you're kind of doing these projects, you're like often, there might be some rules you have, so various projects, there's always some kind of rules. But the rules with this were extensive, and you could say that this was a set of requirements dictated by the Australian government about what determines whether a car is roadworthy, right? So you think about what requirements are and you think, well, it is a definition of success. So they're like, here's a bunch of rules, here's a bunch of descriptions of a system that if you comply with that, you have succeeded at meeting our goal, which is a certain standard of vehicle, right? And I can never navigate these websites, but I was just wanting to show you an example of, yeah, so these are actual real things. These are all the different rules in Australia about what cars need to do. You can think about this as a giant bucket of requirements. So for instance, which ones look interesting to you? Indicators, brake hydraulics, windscreens, steering mechanics, sun visors. There's like literally, like, look at this, rules on sun visors. Those things that you like flip down in your car when the sun's in front of you? So there are whole buckets of requirements on this stuff that you can go and look at. And I like this example because they're not telling you how to design a car. They're not saying, it needs to have... they're saying every car that you've seen in Australia complies. 99.99% of cars you see comply with this. They're all different design. They're all different, made up differently. They all go through different amounts of testing, but they all comply with the same set of requirements. And there'll be a whole bunch of random stuff here. Like, where's an easy one to read? This one's a very, very short one, but... sorry, let me just... Specific requirements. Okay. The sun visor shall be constructed of or covered with energy absorption materials nominally over the whole area such that the requirements of falling asleep. So basically they're saying if you have a sun visor, it needs to be of some material that can absorb energy. And then they're like, read this one to see more. When tested with this, the test sample shall arrest a moving head, so it'll stop your moving head in such a way that the deceleration does not exceed 80 times the acceleration due to gravity, except during a period of less than 3 milliseconds. Oh, like what does that even mean, right? So like I find these examples interesting because this is a very extreme example of requirements. This is kind of getting into the massive regulatory area that you'd imagine big companies like space companies and aviation companies and everything else have to comply to. But this is the Australian government setting a ton of requirements. Now, the reason this is a difficult topic is because there really is no tactile understanding of requirements, I think, because it is so broad. For instance, you could argue that these are requirements put down by the Australian government on car manufacturers, right? But within a car manufacturing company, because if you imagine you've got your like Oz government over here and they have a bunch of requirements that are called the ADRs for cars. Then over here you have your company like Toyota. And Toyota are going to go through, a design phase where they sketch things up and they plan it. They'll go through like a building phase, some kind of quality assurance, which, you could call testing, etc. And, that's trying to generalize this a bit too much maybe with software. But what you'll also find is like Toyota or any car company don't just like take these rules per se and then go and design a car. They might have their own set of requirements that they need to work with. For instance, Toyota cars might all need to have the same kind of electrical equipment so that they're all kind of compatible and technicians can work with them. So requirements aren't just like a thing that's like you do requirements and so does whatever. It's actually kind of like, well, the government has a set of rules that define success. And then you come over here and like, your organization might have more rules that define success or potentially add more capabilities or put more constraints on it as well. Some manufacturers would consider some of the rules in here too generous, and they put even more on there. Like all those really safe cars you see would look at some of these and think, great, but that's like way too unsafe. I don't know what airbags, is there airbags here? I don't know what the rules around airbags are, but it's like some people would take it even further, right? So don't think of this like that static a thing. It's like, sometimes these two things might be combined together. Whatever it is, whoever's doing it, however many people are doing it, however much comes out, all we're dealing with when we talk about requirements in the context of engineering is coming up with a set of rules that define success for people to design, implement, and test to. Because all of this stuff here kind of comes back and gets benchmarked up here. It all gets validated, checking if the right system was built, back to the requirements. So that's what requirements are. We didn't manage to get the car road legal in the end. We ran out of money. We got very close though. It was very, very challenging. The main hurdle we had, I think, was, I can't remember what the main hurdle we had. It was like 6 years ago now. 6.5 years ago now. It's a long time. So this is all well and good when you get given a document. But the real question is then, how do you actually define requirements yourself? Right? This one is really hard. And I want to come up with an example with all of you that we can explore. A problem space that we can explore together. This is the kind of stuff I do every day. I was doing this kind of thing last night. Maybe not as structured as this, but, there's like a broad thing we need to solve. Think about trimesters again. UNSW wants to go from semesters to trimesters. UNSW wants to go to online teaching. All of these things, someone starts and says, here's an idea. Here's a very broad problem or opportunity space that we need to explore. Let's actually figure out the rules that define success. So to get our requirements, we want to go through a process of requirements engineering. And this process, you could broadly say, is made up of 4 parts, which is elicitation, analysis, specification, and validation. Now we're going to run through what these 4 parts are in a sec, but let's just first talk about requirements engineering as a whole. Requirements engineering is a set of activities that is focused on identifying the purpose and goal of a software system. That makes sense. Requirements engineering, you could say, is a set of activities to determine requirements. And what do we know requirements are? Well, they describe the purpose and goal of a software system. We've talked about this a few different ways. A more interesting, because that was kind of obvious, right? Like, we need a process to come up with requirements. So that one makes sense. The second one, though, is more interesting. A negotiation process where stakeholders agree on what they want. And this is a really important part of this idea of requirements engineering or coming up with requirements, is that it is arguably one of the most soft touch human parts of the whole process. I know we just pulled up this kind of giant, scary, legalistic looking document before, but that would have come out of a whole bunch of stuff. Like, you think about these rules, the Australian government doesn't just come up with rules, right? they talk to industry all the time. You know, they have advisory boards. They figure all this stuff out. It's the same with the uni. Whenever the uni makes decisions about programs, they have boards of academics. They have boards of industry. They have boards of alumni. They do all this thing. And it's a big negotiation process to figure out what is the purpose and the goal of the system that we're trying to build. So the reason I point this out is because it's very human, and that kind of ironically makes it the most important. And the reason I think this entire topic is so interesting is because I think when students when you start doing software, when you start, 1511 or whatever, and you think, wow, I can write C code. What ends up happening is that I think it's easy to overlook the fact that your ability to program doesn't really mean much. It really doesn't. And if I go back to this thing here for a second, I mentioned that you start off in the green category, writing code. Then you might test a bit of code and design a bit of code. What are you competing against, right? What are you actually competing against out in the real world? Are you dealing with, you're trying to get other programmers and beat them and get better jobs than them or everything else, right? You're all competing for the same spots at Google or something else. You need a way to stand out, fundamentally. And being a good programmer is rarely going to be like that for most of you, because realistically, there's a great bunch of online courses out there that teach you how to program, bunch of boot camps. There's a whole bunch of very cheap labor out of Southeast Asia and other parts of the world that are as good at programmers as you, right? Just because you've been to university doesn't mean that there aren't people out there that you can pay $10, $15 an hour to actually produce good code. What's going to make you stand out is your ability to understand the blue and the purple, and in particular the yellow. In any kind of job you get, particularly in a country where you're speaking your native language because of how big a deal communication is, because anyone can write code. Not anyone. Tons of people can write code. Tons of people that are going to work for cheaper than you are going to write code, right? Where you can be different is that you can write better code that's better designed, and you can write more robust code that tends to be better tested. That's a good level up, generally. The next level up is to be someone who can actually communicate, consolidate, and negotiate. And that's where most people get paid a bunch of money. I mean, you look at big companies, team leaders, group leaders, all this kind of stuff, like engineers like you that move through the ranks. The further up they go, a lot of the time they're not spending time writing code because they know anyone can write code in that world. They're spending time actually figuring out how to design systems, or even more than that, figure out what problems you're trying to solve. And that's what the best engineers do. The best engineers are not writing code, they're figuring out systems. And I mean, I was in a call last week with a UNSW alumni from 20 years ago who runs their own cybersecurity firm, right? It was a group call. And, they were just talking about they haven't written code in 16 years, but every day they're meeting with engineers and, giving them guidance on their problems and helping them understand if this is the right approach. And that's frankly where a lot of big success can come from. Now, is that to say that if is programming the bottom of a rung? It's no, not really. There's some really, really talented thinkers out there who are just really good at understanding software systems intimately. The kind of types that know a language back to front and are part of the development community and might be contributing to the open source of Python or something. That's quite extreme, but it's there's definitely space there, right? But out of however many students do a course like this, 1,000, not everyone's going to end up being a superstar for their awesome programming abilities because they can write the best Python. Because for a lot of people, that's just kind of a spot. So anyway, that was a very kind of meaningful, though maybe slightly distracting tangent, which just kind of came to my mind then while we were talking about this, because I was thinking about negotiation, and it's that's why you're valuable. And I know this is kind of annoying, right? Because a lot of people get into programming, they're I love this because I can just sit down and write code and leave me alone, And it's you can do that. Thankfully we live in this great industry where you can just sit down by yourself and code, and you'll probably earn a bunch of money, more than most people, because of how affluent the software industry is. But in my experience, you tend to see better success for yourself if you actually embrace that there's a human element to things. And I've seen this as well in industry plenty of times. you have 4 engineers, they can all program fine, but the one who's actually interested in designing systems or even figuring out what the problem is and having meetings and whiteboarding and doing designs and asking questions and talking to customers and actually interviewing potential customers or clients, they're the ones who are by far more valuable on average. Camille says, how does requirements analysis tie into clients getting quotes for software work or a tender process? That's a great question. In the world of software engineering, you've got all this stuff from, I guess, on 2 ends of the spectrum, right? You're working as like a code monkey for Google, where you're on a team of a team of a team, and you're just writing code, and it's very focused on technical. And then on the other side, you might be working for some kind of consultancy or even a small business yourself that's just focused on producing work, right? I've seen this. I had 2 friends from uni who did 1511 with me. They went and started a company where all they did was build software for businesses. They just went out to random businesses who were looking for software, and they went and sat down with them for a few days, talked about everything they need, tried to figure it all out, and then said, this is how much it's going to cost, and then the business might say, yep, build it, and then they go and build it, right? So that first part there is all about requirements, and that's kind of where a lot of this stuff fits in. It's about scoping out the system. At the end of the day, an engineer is going to have to build the thing, but you tend to get better results when you have engineers part of the negotiation process. And you know what? It's not even like, they send engineers out into the big bad world to figure something out, right? Like when someone says, we need to move online. UNSW needs to move online. We need, Microsoft Teams and Zoom licenses and stuff. It's not like they just say to, engineering teams of people, go and figure that out. It's often that, there will be actual people who are product managers and other project officers who just work with engineers, So it's just a very useful skill to have because people will value your input and consider you much more valuable. So back to this. If we think about requirements engineering, the process of generating requirements as a negotiation process, as a very human process of figuring out what in the hell the goal and definition of success of the system is, you have to talk to stakeholders. You have to go and actually chat to people. And I'll give you an example. Again, in my role, which is looking after product and engineering for a financial piece of software, whenever we do stuff, we have a couple of key stakeholders, which are the engineers, customers, and our commercial or legal team. Because everything we do, we need to actually be interested in what our consumers, the people you're building it for, care about. That's you in the context of the uni, right? Most things that happen at the uni, they talk to students in some way. Maybe not enough, some would argue, whatever. That's not what today's about. It's like, they do it to some extent because your students are a stakeholder. You talk to engineers or you talk to your staff a lot of the time because they're going to be the ones executing on it. So when they do a move to trimesters at UNSW, they do talk to staff because they're going to be the ones dealing with it, and they get their feedback to understand what's a good system. And then in the case I mentioned about, a financial company, because a lot of what we do is very, has a certain level of intensity to what degree, finance is a big scary industry with lots of rules and stuff. You tend to need to talk to someone and say, can we do this? I'll give you an example. We were scoping out a system the other day to make it easier for people to save money into a thing, and we were going to charge them money at the start of the month. Let's call it $1 a month. $1 a month, and we'll help you save money and make that money bigger, right? I'm generalizing it a bit here because I can't talk about it, but and we went to the legal teams, and they were like, yeah, that's a good idea, but you can't charge at the start of the month. You have to charge at the end of the month. Customers won't care, right? Like most of the customers wouldn't care. The engineers didn't care. Most people didn't care, but from a legal standpoint, they were like, there's pretty strict rules in Australia that a finance product, you can't charge for services yet rendered. You have to charge in what they call arrears at the end of the month, right? So that's why this is a big complex project full of different stakeholders, because there are lots of different voices that weigh into this for different reasons, and it's all about bringing it together. So when it comes to this 4 steps of requirements engineering, I mentioned before elicitation, analysis, specification, and validation. At a high level, elicitation is about collecting everything. Analysis is about organizing everything. Like sitting down on a desk and piecing it all together. Specification is about coming up with something that's finished. And then validation is about going back to the same stakeholders and saying, how's this? Is this good? Does this capture everything? You know, and that's kind of like a fairly straightforward process. So if we look at elicitation, this is kind of one of the this is the most interesting as far as I'm concerned, because it's the one not talked about, which is just like, just learning what you can. Because again, when you come up with requirements, let's say again, moving UNSW totally online, or, you know, going to quadmesters or something, like four terms a year, or God knows what. You need to learn, and you need to ask questions. You can do market research. You can ask, you can do focus groups, right? So let's say I want to change 1531 in a way. What's a way we could change 1531? Well, we could remove the labs. You know, we could be trying to rethink about how the labs work and take all the marks off the labs. Okay, so, well, what's some things we can do? We can go and send out a survey, right? We can do some market research. We could go and put out a poll to all the students. What do you think of this? Do you like it? Do you dislike it? Do you not mind? You know, so there's a whole bunch of quantitative stuff you can do. You can go to focus groups, as in you pick, like, you know, say 3 students at random and another 3, and you do like a call with them, and you just chat to them about it. You say, you know, like, what do you want to see? And then you take some notes, and it's very, like, very deep, you know, meaningful and all of that. More detail. You're going to be subsampling, but, you know, there's more detail there, and you just collect information about it. You know, whatever that information is. Elicitation is about pulling as much as you can in. And you kind of get this, right? Like, who remembers doing, like, think about, another way I like to talk about this is, do you remember doing research essays in high school? I'm sure many of you did something like this in high school. Like, write a 4-page essay or report on the effects of acid rain in the northern hemisphere or something, right? Or like write a report on, you know, the impact of the World War II on the rate of physical science developments. I don't know. And, like, remember what you did. Like, you kind of went through this process for a whole different reason. It's not, I wouldn't call that requirements, but it's like, what would you do? You do a lot of Googling. You collect a whole bunch of notes sometimes. I know this is not how everyone works. You then start organizing the notes, which is step 2 analysis. You then start kind of coming up with a draft, which is like step 3 specification, and then you might get a teacher or someone else to look at it, which is validation. So this is a very natural process we all go through for a ton of things anyway. So elicitation is the most important, and it's the most human part of it. Analysis, as I said, is about, once you've got all this raw stuff, categorize it. Break it into different chunks. Be like, all right, yep, that's related to this, that's related to this. Figure out what are constraints and risks. There's no table I could give you here where it's like requirements analysis is just like identify conflicts and risks and dependencies, and that's it. Because different kinds of activities would dictate different things. Sometimes you would, sometimes you might categorize this into best case and worst case. So you think about the thing where I say to students, okay, let's have a look. Let's explore a different assessment structure. Bigger exam, smaller exam, bigger project, smaller project. You're going to go a whole bunch of things. Some students say, oh, bigger exam, that's so stressful. It's 3 hours of my term that determines my life. Then other students say, yes, please have a bigger exam. I'm in control of that and I'm not dealing with my group. You're going to get both of those things. You know, how do you weigh those up? How do you define those as risks? How do you collate them together? That could kind of go on forever. Ways you can build this picture here are actually part of our second lecture after the break, which is around use cases and user stories. So I want you to remember this point. Once you get a bunch of information from people, the analysis or the organization stage, we're going to talk about some more formal ways to do that soon. So, this is just collecting it all together. Specification is saying, all right, well, let's actually get rid of the noise now and put something back together. Think of it like a draft summary of things. If you imagine for a second that, when we write the project spec, we sit down, we talk to the tutors, and sometimes we talk to some ex-students, and particularly ex-students who become tutors, and we say, okay, well, what do you think's a good set of things this project needs to do? Oh, we should teach, we should give them some problems that if they don't communicate, they're going to do really bad at. We should give them some stuff that focuses on, this was written so long ago now, I don't remember what the specifics were. we should make them have a sense of storing data persistently. Stuff like this, And then you eventually come back and you produce a draft, and you might give that back to the stakeholders, right? But the actual producing of a draft production of a draft picture of things is essentially what this specification's about. It's actually bringing it all back together now. You've got it, you've analyzed it, let's bring it back together. And then lastly, we have our validation, which is like making sure you didn't stray off the path, making sure you're still doing the right thing. Go back to the stakeholders, say this is what we've come up with, and they'll say, oh, this seems to be missing that thing that was really important to me. And the answer there is like, you're right, that is missing that, thank you. Or the answer might be like, sorry, but you were the only one who cared about that, and we interviewed thousands of people. So that's kind of that process there. Now, what are some challenges that you might face in this process or experience? Well, I could tell you a few. One of them, requirements are sometimes only understood after designing or building has begun. You've probably noticed this from your own project or any other kind of software project. Sometimes you don't actually understand the goals until you work with it, and sometimes the goals change as you work with it. And this is a very soft balance here, and this is why we see this kind of iterative design in the world of software in particular, because the requirements are always changing, right? Think about this for a second. It's like why do the designs of websites change? Why does Facebook look different every 2 years, or why does other stuff look different all the time? It's because the needs and the goals, the definition of success changes as people's tastes change, as technology changes, right? So there's lots of things that can't just be understood at the start forever. It's a constant renegotiation process. That's why we call it the software engineering life cycle, not the software engineering sprint. I don't know what you'd call it. Start, stop, go to sleep forever. Sometimes clients and customers don't know what they want. This is a really big challenge. Sometimes you will talk to students who will say things like, I don't like the idea for tech quadmesters because I don't want to do that. And it's like, maybe they don't understand how the benefits could be, right? Because everyone can only give as good feedback. Everyone's feedback can only be as good as the information they have to understand. Sometimes they change their mind. Sometimes developers might not understand the subject domain. Maybe you're trying to build a system for online learning as a network engineer or something. But maybe you don't know a lot about education. Maybe you don't know a lot about the life as a student. Who knows? Sometimes you see people design courses, young people design courses for older people, and they get it wrong because they don't understand the context. Sometimes you don't have access to stakeholders all the time. You can't often just call people up. Sometimes you only get to ask them questions a few times because the people that you're relying on to help you determine the requirements are busy. You can't just be like, I have this random question. Sometimes you have to collate them up. That's why we get you to write an assumptions doc in iteration 1, because we don't want to clarify all of your assumptions for you, because it's very, very real that you can't just you run into a point of ambiguity. You have to make a decision on it, document it, so that it's written down somewhere. And you know what? Maybe in a week you could sit down with a stakeholder and be like, these are the assumptions we made. And they're like, yeah, they all look good. Yeah, that makes sense. No issues there. And then the last one is jumping into details or solutions too early. I don't remember if I've talked to you all about XY problem this term. I lecture enough that I often forget this. I believe it was talked about. I don't know, someone can remind me. I know we talked about it in 2521 last term, which I know some of you are from. But I do just want to mention it again because I think we're at the end of this lecture now and we can take a break. But I'll mention it again, even if I've mentioned it already and gone through it already, because it's very relevant here once again. Definitely mentioned it this term. I did. I know. I talked about this. I sent you the link to the XY problem. I think I talked about it with design or something like that. The thing I wanted to point out, right, because we already talked about this. I'm not going to talk about it again, run through it. But the reason this is really interesting is mainly in the world of requirements. And again, when it comes to this negotiation process, when it comes to this requirements elicitation from people, this is actually one of the most important things you need to keep in your mind. Because if you're talking to someone, you know, like a student or, you know, a client or a consumer, customer, whatever, and they tell you what they want, you have to be very, very careful that you're trying to extract from them the problem and not their desired solution. Okay, I gave you the example about the fork and the chopsticks, I believe. Yep. And it's like when you're talking to stakeholders and you're trying to extract what defines success, you have to be really careful. In DESN 2000 and 2020, you know, we kind of gave students this opportunity to interview, not real, like, you know, their friends and stuff. They were building like a smart Opal system in Sydney, like a smart transport tap system or something like that. And it was really interesting because it's human nature to go to people and say, you know, what do you want from this system? And they're like, oh, I really want this particular feature on my phone. But in actual fact, they do want that feature, but that's just because, you know, they have a problem that they want solved. So focus in more on that problem. So when you're doing this kind of elicitation, when you're doing this understanding and negotiation, focus really hard on the problem. Students don't hate trimesters, right? I mean, from my assessment, it's been going on long enough now that hating is just a meme and it's just life, right? Like, you know, everyone doesn't like change naturally, but it's like students aren't like trimesters are a terrible idea. That's what I hate. It's kind of like, I don't like being tired. I don't like feeling compressed. Even if I'm working the same, I don't like feeling compressed. I don't like doing, you know, one thing really hard for 3 weeks and then another thing really hard for 3 weeks. I'm the kind of person that would rather do 10 things slowly at the same time. You know, and this is really important when it comes to elicitation, because you often have to probe into people, and they say things like, I don't like this thing. I don't like online learning. It's like, okay, why? Do you feel isolated? They say, yeah. They're like, do you feel like you have access to less material? They're like, no. Do you think the education's worse? They're like, no. You're like, okay, so it's not that, you know, the requirement isn't that we want to avoid online learning. It's that community and connection is really important. That's your requirement there. So there's definitely an art to actually coming up with this set of requirements as part of this process, where you actually have to probe and learn more about the person. That's why I say it's very human. You know, it's not just like this mechanical process of jotting things down. So this takes us to the end of the requirements engineering lecture. Yeah. So let's take a break till 11 o'clock, 7 minutes. Fill this in. Please pause the video and fill this in. Thank you.